Are you able to see?
Yes, sir.
Yeah. A company called Borduria Energy owns a nuclear power plant and a gas-fired power plant. Its trading division has entered into the following contracts for 25th January. So transactions are listed out here in numbers. That is T1 is transaction 1, T2 is transaction 2. Similarly, it goes till transaction 9. Okay, 9 transactions. In addition, some other transactions are also there. Now, transaction 1 says that a forward contract for the sale of 50 megawatts at a price of $21 per megawatt hour. This contract applies to all hours, irrespective of whether it is an off-peak hour or a peak hour. It applies to all hours. Now, transaction 2 says that a long-term contract for the sale of 300 megawatts during off-peak hours at a price of $14 per megawatt hour. Transaction 3 is a long-term contract for the sale of 350 megawatts and at $20 per megawatt hour during peak hours. Now, in addition to these 3 transactions for the trading period from 2 to 3 p.m. on that day, that is 2 to 3 p.m. in the sense it is a peak hour, because peak hour is defined as 8 a.m. to 8 p.m. So 2 to 3 p.m. comes under peak hour. Okay. Now, in addition, for the trading from 2 to 3 p.m. on that day, it has entered into the following transactions. So these are basically derivative market transactions. Transaction 4 is a future contract for the purchase of 600 megawatt hour at $20 per megawatt hour. Then transaction 5 is a future contract for the sale of 100 megawatt hour at $22 per megawatt hour. Transaction 6 is a put option for 250 megawatt hour at an exercise price of $23.5 per megawatt hour. Then transaction 7 is a call option for 200 megawatt hour at an exercise price of $22.5 per megawatt hour. Transaction 8 is a put option for 100 megawatt hour at an exercise price of $18.75 per megawatt hour. Then in addition to these transactions, there is T9, which is a bid in the spot market to produce 100 megawatts using its gas-fired plant at $22 per megawatt hour. Now, the option fee for all call and put options is, 1 minute, let me see whether T10 is there. I doubt whether T10 is also there. Just a second. I have missed out. One minute. Let me see. I think. Okay, T10 is there. T9 and T10. T9 is, you can write down a bid in the spot market to produce 50 megawatts. A bid in the spot market to produce 50 megawatts using its gas-fired plant at $19 per megawatt hour. So this is in addition to the 100 megawatt production, the commitment on 100 megawatt production, the bid on 100 megawatt production to the spot market using its gas-fired power plant at $22 per megawatt hour. So in total, 10 transactions are there here. Okay, so 50 megawatts at $19 per megawatt hour and 100 megawatts at $22 per megawatt hour. So in addition, this is also there. I think that is not that 50 megawatts transaction is not shown here. Okay, the option fee for all call and put options is $2 per megawatt hour. The peak hours are defined as being the hours between 8 a.m. and 8 p.m. Borduria Energy also sells electrical energy directly to small consumers through its retail division. Residential customers pay a tariff of $25.5 per megawatt hour and commercial customers pay a tariff of $25 per megawatt hour. Borduria does not sell electricity to industrial customers. Now, during that hour, the residential customers served by Borduria Energy consumed 300 megawatts, while its commercial customers consume 200 megawatts. Tariff is given here, so at that particular rate it will be sold. The nuclear power plant produced 400 megawatt hours at an average cost of $16 per megawatt hour. Its gas-fired plant produced 200 megawatt hours at an average cost of $18 per megawatt hour. All imbalances are settled at the spot market. Now, two things are asked. Calculate the profit or loss made by Bordoria Energy during that hour if the spot price at that hour is $21 per megawatt hour. This is the first part of the question. So similar to the previous question we solved, here also to find the profit or loss, we are dividing the transactions into two. First is physical transaction and second one is financial transactions. So the profit or loss made by the company from derivative markets plus profit or loss made by the company from other contracts. These are separately solved or worked out, and the sum of these profits will give you the total profit. Now let us see how the solution is. Okay, let me zoom out because it may be a bit small, but are you able to see now? Are you able to read this?
Yes, sir. Yes, sir. Yes,
Yeah,
sir.
yeah. Otherwise, you will not see the full figure. That's why. Okay. Okay. Now you can see Bordoria Energy is represented by the rectangle in the middle. So it has two contracts. To the right side, you can see this green colored arrows. It has two contracts. 300 megawatts is produced for the residential customers at $25.5 per megawatt hour, and 300 megawatts. This 200 megawatts is produced for commercial customers at $25 per megawatt hour. Let me open the question part again. We'll see the. Okay. Okay, so here Bordoria Energy also sells electrical energy directly to small consumers through its retail division. Residential consumers pay a tariff of 25.5 and commercial customers pay a tariff of $25 per megawatt hour. And here it is given that residential customers consumed 300 megawatts and commercial customers consumed 200 megawatts. So that is what is I mean, these transactions are to residential and commercial customers. So these are revenues basically. So we mark it as revenue 1 and revenue 2. Now let's go to T1 and T3. What are T1 and what are the transactions in T1 and T3? T1 is a forward contract for the sale of 50 megawatts at a price of $21 per megawatt hour. This contract applies to all hours. Here you are asked to find the profit or loss during 2 to 3 p.m. This applies to only peak hour, but this particular contract T1 applies to all hours. So it applies to peak hours as well. Now the second contract T2, you see here, this is for off peak hours, this contract. So we need not consider the second one because you are asked to find the profit for the peak hour only during 2 to 3 p.m. So this we are going to discard. Now the third one, T3, a long-term contract for the sale of 350 megawatts at $20 per megawatt hour during peak hours. So this should be considered. So both these contracts are sale, right? So these are revenues. So that is what we are going to mark next here. T1 and T3, 50 megawatts at $21 per megawatt hour and 350 megawatts at $20 per megawatt hour. T1 and T3, revenues 3 and 4. So this was revenue 1, revenue 2. This is revenue 3 and this is revenue 4. Now, what we are doing is we are identifying revenues and expense separately, and we are taking revenue minus expense in the physical market first, and we are going to find the profit in the physical market. Then we are calculating revenue and expense separately in the derivative markets or financial markets, and we find the profit there. By calculating revenue minus expense there, and we are going to add both the profits. Now we are going to check whether any other revenue is there. So here you can see another transaction is a bid in the spot market to produce 50 megawatts using its gas-fired plant at $19 per megawatt hour. So this is another revenue, but you can see one more. Actually, T10 is a bid in the spot market to produce 100 megawatts using its gas-fired plant at $22 per megawatt hour. But it is given that the spot price is $21 per megawatt hour. So as the offer in transaction 10 is greater than the spot price, this is not qualified. This transaction 10 is not qualified. Transaction 9 is qualified. So for calculating revenue, you only consider T9. You don't consider T10. Okay, that is what we see here. In the spot market, revenue 5, we already got revenue 1, 2, 3 and 4. In addition, you are getting revenue 5, 50 megawatt hour at $19 per megawatt hour. But $19 per megawatt hour is the offer price. What is the market clearing price? That is a spot price, that is $21 per megawatt hour. So while calculating revenue 5, you have to use $21 per megawatt hour. Okay, so these are the revenues from the physical market. Now we have to find the expense. Parts of expenses in the physical market. Now you see here how much is produced by, how much is self-generated by energy. That is also given in the question. That is okay, here. The nuclear power plant produced 400 megawatt hour at an average cost of $16 per megawatt hour. Its gas-fired power plant produced 200 megawatt hour at an average cost of $18 per megawatt hour. So these two are expenses for the company. So that also we are considering here. Production for production of energy, 400 megawatts at $16 per megawatt hour and 200 megawatt hour at $18 per megawatt hour. So these are expenses 1 and 2. Okay, expenses 1 and 2. Now, what is the other expense? It is also given in the question that all imbalances in the market are settled through spot market. So now we have to find whether the company is buying anything from the spot market to balance the market, or whether there is any deficiency. If there is a deficiency, then it would be bought from the spot market. So now you can see here 500 has commitment. 500 the commitment of 500 is there for residential and commercial. Then 350 plus 50, 400 is there in the forward contract and the long-term contract. So this 400 plus this 500 gives you 900, right? And another 50 megawatts to the spot market. Selling to the as a part of selling to the spot sale to the spot market is there. So this 50 plus this 400 plus this 500 gives you 950. So the company has to find 950 megawatt hours for honoring its commitments. So now how much is produced by the company? 400 plus 200 is only 600. 600 is only produced by the company. So 350 it has to balance, or 350 it has to compensate from the spot market. So it is buying 350 megawatt hours from the spot market at market clearing price, or the spot price, which is $21 per megawatt hour. So this is another expense, expense number 3. So expenses 1, 2 and 3 here, revenues 1, 2, 3 and 4. So this will give you the total revenue minus total expense in the physical market and the total profit in the physical market. So that is the next step. Here what we are going to do is revenue 1 plus revenue 2 plus 3 plus 4 plus 5 minus expense 1 plus 2 plus 3 will give you the profit in the physical market, which is $4,400 per hour. This is what you get. Now coming to the derivative market, this is the profit from the physical market. Now coming to the derivative market, how many transactions are there in the derivative market? T4, T5, T6, T7 and T8. Let us see what are the transactions, the given data of these transactions. T4 is a future contract for the purchase of 600 megawatt hour at $20 per megawatt hour. So this is purchase, right? The strike price is 20, right? The spot price is 21. So purchasing at 20 is better than purchasing at 21. So the company will have a gain there. The gain will be 21 minus 20 into 600. So that will be the first for the first derivative market transaction. 21 minus 20 into 600 equals $600 per. That is a profit for this particular transaction T4. Now moving on to T5, a future contract for the sale of 100 megawatt hours at $22 per megawatt hour. This is a sale contract, right? Strike price is 22. 21 is the spot price. So definitely it will have a selling at 22 is better than selling at 21, right? So this has to be exercised also. This is an obligation because this is a future contract. It's not an option contract. So it is exercised and it has $1 per megawatt hour profit for every unit. So 1 into 100 will be the profit from this particular transaction. So 22 minus 21 into 100 is $100 per hour. Now moving on to T6, a put option for 250 megawatt hour at an exercise price of $23.5 per megawatt hour. What is a put option? It is a sale, right? So this is the exercise price 23.5. So sale at 23.5 is better than sale at $21 per megawatt hour. 21 is the spot price, right? So already 2.5 profit is there per megawatt hour, but it says that for all put options there is a fee of $2 per megawatt hour. So what happens here is 23.5 is the exercise price minus 2. He gets, this is expense. This is upfront expense for the premium, option premium. Then minus 21. This is the spot price. So 23.5 minus 2 minus 21. The contract amount is 250. So that is multiplied by 250, and you are getting $125 per hour. Again, it is a profit. Okay, because this is basically 250 into 0.5. $0.5 per megawatt hour is the unit profit he is getting, considering the upfront premium cost and the quoted amount, the strike price and the spot price. Now going to T7. What is T7? T7 is a call option for 200 megawatt hour at an exercise price of $22.5 per megawatt hour. So a call option is basically what is call option? Anybody?
Buying power.
Buying. So buying at an exercise price of 22.5, is it better than buying at 21? No, buying at 21 is better, right? So there is a difference here. So it's better not to exercise it. But even if it is not exercised, the problem is the upfront cost is gone. Upfront cost for the premium is gone. So he is not going to exercise it, as it is an option contract. It is a choice of the holder. So he's not exercising it, but this 2 is gone, right? So minus 2 into 200, this is lost. So minus $400 per hour. Now coming to T8, a put option for 100 megawatt hour at an exercise price of 18.75. So this is sale, right? Sale at 18.75 is a loss when compared to sale at $21 per megawatt hour. So he's not going to exercise it, but there is an upfront cost of $2 per megawatt hour. So he is not exercising it, but as per the quantity quoted, there is 100 into minus 2, which is minus $200 per hour. So this is also a loss. Now you are adding all these, considering the negative sign also, because negative profit is loss, right? So you are considering this. So you are getting $225 per hour from the transactions T4 to T8 as the profit. Now you add this with the profit from the physical market. So $4,400 per hour was the physical market profit. This is the derivative market profit. So the total is now $4,625 per hour. So that is what is the solution for the first part of the question. Now, 1 minute.
Sir, you are on.